Hello, my name is KAESHAV RAMIS. My metric number is 2210633027. Today I'll be giving the introduction for our case study slide. The purpose of this case study is to identify face mask use. This case study's main goal is to create a reliable system that uses Matlab to identify the precise way people wear face masks and to automatically reject situations in which masks are worn incorrectly. The goal is to improve public safety by using computer vision techniques to ensure proper mask usage, especially in settings where mask adherence is critical. The COVID-19 pandemic and other continuing worldwide health issues have highlighted how crucial it is to use masks correctly as a preventive strategy. The challenge of ensuring that masks are worn correctly and consistently in public areas has made creative solutions necessary. This study uses cutting-edge technology to identify and rule out cases in an effort to overcome this difficulty. If masks are to be as effective as possible, they must be worn correctly. By creating a system that actively rejects instances of improper use in addition to detecting mask usage, the goal is to support public health campaigns by adding an extra degree of protection to public settings. Although computer vision has been used for mask identification in the past, this case study brings a fresh perspective by concentrating on the manner in which masks are worn. It is essential to comprehend differences in mask alignment, coverage, and tightness in order to recognize improper usage patterns. This work extends the body of knowledge in pattern recognition, image processing, and computer vision and applies it to the practical use of mask wearing compliance. Because of its vast capabilities in computer vision and robust image processing toolkit, Matlab was selected as the main software for this case study. The perfect setting for putting complicated algorithms into practice, testing, and improving the system for precise face mask identification is provided by Matlab.
As for the methodology, we started with image acquisition. This step involves acquiring and sampling images for both training and testing. The path to training and testing data were specified. The categories that we considered were mask, no mask, and not properly worn. For each category, images were loaded into temporary data stores. In the data store, subfolders were included and used for labelings. Then we proceeded with image processing. This phase involved feature extraction and encoding using the bag-of-feature approach. Extractions of labels for training and testing dataset from the respective image data stores were done. Following with training of SVM classifier, it went with preparations of data, which is initializing and model training the SVM classifier using encoded features corresponding labels. The trained SVM classifier were used to make predictions on the test set, and it was compared with the actual labels to calculate the accuracy by measuring the percentage of corrected predictions. With all this data, a confusion matrix was created to assess classifier performance.
A very good day. I am Yukteswar Shangar and my metric number is 2210611464. I would like to share my parts about BF on the coding so that here they are. As per said, my scope is about a COVID-19 application. So I'll choose the title for my codings to be a face mask detection so that it will be easy to make out the coding of it as my lecturer said. So there's many classification on it as image acquisition, further extraction, like image processing, further extraction, classification, and at last is about a confusion matrix, a new method as my lecturer said in the previous class. So I would like to share the screen on here to let know about my codings. So First of all, it's about creating a folder about a face mask detection, and I categorize into three. That is mask, no proper wear. So that in it, I choose the 70-30 method, so that it's about 70% training and 30% about testing. So here the images on it and testing and training of here. So then I classify it into three, and then I make it as a coding in Matlab. So first of all, I uh, set the part to my training and testing data. It's about image acquisition process is going through in it, so that the base directory file is about here, and I categorize into three. So it's all about mask, no mask, not properly wear. Each of them I need to have trainings and testing files, so that I combine into one, and that I data store the image for testing and training. And to do the image processing, I use the backup features in here, so that it will be easy for the processing for me. So that is like a further extraction process is overcome in here, so that the backup features like classify into the image into a further extraction things. And after it, my classification is about SPM classifier, as you can see. I've stated about SPM classifier, so that my output could be given in a good way. So finally, as you can see, I use the confusion matrix in it, um, so that you can know the result about how things are working in it, so the calculations and the accuracy of it. So I would like to proceed with my command window idea. First of all, it's create a bag of features, so that the bag of features is that further extraction, so that it extract the 48 image from it, and then keep the 80% of the strongest feature from the images I have stated it below. And then it's about categorizing and creating the cluster of the images, and then clustering is finished. Then it's make the process of encoding of image, test and trains, and after that finally using the bag of features to create the confusion matrix of it. So this is the output, and the things are created in this MATLAB software. So there's a this is the confusion matrix table that I get from the MATLAB things. And other than is about accuracy and confusion metric data, so that as you can see, it's about 70.833% accuracy I obtained from the MATLAB data at here. So my image processing worked well as per said, and that's it from me. It will create a good software, and will help COVID-19 application to work well. And that's all from me. Thank you so much.
Good day all, I'm SUJENTHERAN MUNIANDY. My metric number is 221061456. Here I want to present about the result and discussion of our case study. First of all, the COVID-19 epidemic brought attention to face mask detection technology. The distinction between wearing and not wearing a mask was the focus at first. In order to go deeper, our case study added a third category, that is not properly wear. This includes masks that rest loosely on the face, cover just the lips, and dangle below the nose. We also have included some sample photos of people wearing masks and not wearing masks, and wearing masks improperly in this case study. So we have uploaded the image to the training and testing files in the two sets of parts. The test files and the train file dataset will be combined and encoded. The sample image will be categorized using the SPM classifier into the following groups. That is mask, no mask, and not properly wear. Consequently, the outcome is shown in the image below. On the test set, the train classifier is used to generate prediction, and the model accuracy is computed and shown. And additionally, we also had the confusion matrix is created and shown in the result below. So here is the result for our case study. As you all see, I have three different output here. The first one is the picture shows that result for not properly wear. The second one shows no mask, and the third one for the mask output. From our case study, we can classify 3 of these categories as we shown here. So here is the result of confusion matrix. So it's created and presented for detailed insights into classifier performance for each class. So from this we also can get the graph of RACI.
Hi, my name is Navin. Now I'm going to explain the conclusion. In conclusion, our successful development of a face mask identification system using Matlab, incorporating machine learning algorithms and image processing techniques, addresses the vital objective of determining proper face mask usage to enhance public health and safety. The model and trained with a diverse dataset of individuals wearing and not wearing masks demonstrated high accuracy during testing, showcasing its effectiveness in discerning mask presence. The integration of Matlab's image processing toolkit facilitated offensive feature extraction, enabling the model to identify crucial facial features and mask patterns, while recognizing limitations such as sensitivity to lighting conditions and face shapes. This project looks toward future integration with more advanced algorithms to address these challenges. Our MATLAB-based system provides a practical solution for automated mask detection in images, underscoring the potential of computer vision and machine learning in supporting public health initiative. Ongoing research and development remain crucial for enhancing the accuracy and robustness of these systems in real-world applications. That's all from me. Thank you.